All right, here is a quick note set on how to do the math for the kinetic and potential energy equations. So we'll start with the kinetic energy. So kinetic energy is 1/2 mv squared. So when we're talking about kinetic energy, our unit for kinetic energy is in joules. So go ahead and make sure that you type that in to what you're doing. We shorthand kinetic energy KE, but the actual unit for joules is J. Mass is measured in kilograms, and velocity is measured in meters per second plus a direction. So again, it's 1/2 mv squared. We're using our power triangle here. Kinetic energy equals 1/2 times mv squared. Remember, anytime you're going across, it's multiplying, and anytime you're going up and down, it's dividing. So use your power triangle here to make sure that you're solving for your problems the right way. So if we read our first problem, it says a 43.6 kilogram toddler hits their parent with a velocity of 7 meters per second. How much kinetic energy does the toddler have? So if you are struggling with word problems, I really recommend that you use the Kami app to help critically read those problems, to help circle what you're solving for, and to identify the different things within the problem itself of what your units are and your variables are. So we're solving for kinetic energy. So we know that kinetic energy equals 1/2 m times v squared. So I'm going to rewrite that for myself because I like to have my equation down here, and then I like to plug in my variables. So then when I do that, I see that my mass is 43.6 kilograms and my velocity is 7. Make sure that you put that squared in here so that you're squaring this, not the whole thing, right? So watch your order of operations. So when I did this, I said 7 squared times by 43.6 and then multiplied by 1/2, or you could obviously divide by 2 if you'd like. So on this one, when I solve for all of this, my kinetic energy is 1068.2 joules. And so our unit for energy is joules again, so all you have to write is that J. For newtons and for momentum, we were able to use our units to cross out and have it make sense. On this one, it doesn't really cross out, we just know that it's measured in joules. So there's your kinetic energy example problem. You have 5 examples, 5 math problems to go through and work on there. So here's your potential energy math walking through. So potential energy is also measured in joules. The mass again is in kilograms. Our gravity, so this is just the acceleration of gravity, so it's 9.8 meters per second squared. And then finally we have our height, which is in meters, which is that little m. So potential energy, we can break up our power triangle here on the bottom and solve. So if I were solving for potential energy, I know it's mass times gravity times height. So there's my equation up here, mass times gravity times height. So if I were solving for the mass, for example, I could say that it would be potential energy divided by gravity times height. So hopefully you can see how you can still use the power triangle even if there's 3 things on the bottom. If not, then this is something that I am happy to answer for you at any time, especially if you are in class that day. I can write that down on the board pretty quickly. So just let us know, any of your teachers really, and they can help you with how to manipulate that power triangle. So if we read our problem here, it says a 3.5 kilogram bowling ball is sitting on a countertop 2 meters above your toe. How much gravitational potential energy, so potential energy, does the bowling ball have relative to your toe? So if we're solving for potential energy, I'm going to take my mass times my gravity times my height. So potential energy, I rewrite my equation again because then I like to just plug in my values. So there's my mass, there's my height. Don't forget that gravity is 9.8 meters per second squared. So when I plug that all in and I multiply, I get 68.6 joules as my potential energy. All right, so there's your walkthrough on how to do your potential and kinetic energy math. That's what you're going to be working on when you are not in class during this week.